Good morning to everyone. My name is Narayana. Now I am going to explain about addition and subtraction of two numbers dynamically. So first of all, we take dot model small. This is used to do in small programs only. If we want to use in large programs, we use dot model large. Next comes to data segment. In data segment, first we used to take four variables named as A, B, C, D. A and B values that values are given by the user dynamically, and C value is addition value, and D value is subtraction value. And N1, N2, N3, N4 are four variables which prints on the screen enter first number, enter second number, additional numbers, subtraction numbers. So next comes to the code segment. It was represented by dot code. Next, initially the data is moved into AX register and AX value is stored in data segment. Next, LEA DX, N1 means load effective address. Means the effective address of the this line enter first number is stored in DX register. Which register? DX register. To print these value, to print enter first number, we use it to store the address of this is stored in DX, and we use this move AH comma 9 and move AH comma 1, which is used to take the number from the user. Number from the user which is stored in a value. Next comes to subtract AL comma 48, which means initially what we wrote on the screen is taken as a hexadecimal value. So we convert this hexadecimal value to decimal value, which was understood by us. So we subtract with our number with 48, then we will get the decimal value. The decimal value is stored in A, which was A value. Next, and the print enter second number message has to print. So we use this LA DX comma N2, which means the same. The address of the N2 is stored in DX. So to print those enter second number, we use this line, these three lines. And again, we need to give number to the system. So we use this 1AH comma 01H or 1. This gives values to the B value. It is stored in B value. Next, again we use here subtraction operation because the hexadecimal value is converted into decimal value. We use this, and which AL value is stored in B value, which was the B value. Next, we use move AL comma A, add AL comma B, which means the A value is stored in AL, and we here perform addition operation, which means add AL comma B, which do operation like AL means A plus B operation. A plus B operation is stored in AL, which AL is also stored value is printed on C value, which is stored on C value. So now the C value contains addition of two numbers. Next, initially AH has some other values, so we first make it as 0 and then add 40 to AH. This is used to convert our addition value, which addition value is decimal value, which decimal value is also converted into hexadecimal, which is understood by the 8086 processor. Next, same. Add those AH and AL. AH means higher bit of the addition value, and AL means lower bit of the addition value. AH means suppose example we should take 1 1. 1 1 means in higher bit we store 1 and lower bit we store 1. This is AH and AL. That AH and AL is in AX register. So AX value is stored in BX. Next, print N3. What is N3 message? Addition of numbers. Now addition of numbers string is printed on the display. So the value printed on the display using these three lines. Now 2 AH comma 2, which is used AH comma 2 is used to print the addition value here. So BH comma DL. 2 is stored in AH and BH value is stored in DL. What is BH? The higher order bit of addition value is stored in DL. And then here AH comma 2 and 2 means AH comma 2 means printing the value, and BL comma means the BL value is stored in DL. The lower bit of this is stored in DL value. Now addition is completed. Now comes to subtraction. First, A is stored in AL because AL has some other addition value. No, that's why we again A value is stored in AL and perform addition subtraction operation. AL comma B, which subtracts AL minus B. AL minus B is stored in AL. So that AL value is again stored in D register. Now again some AH value contains some other things, so we make it as 0 and adding AH comma 48, which means the subtraction value is decimal value. Now we convert this decimal value to hexadecimal by adding 48 to it. So 48 is the ASCII number of 0. So if we add this means we know the processor knows it very easily. So AH comma AL means the lower order bit and higher order bit is added. Now it changes to hexadecimal value because AX value is stored in the subtraction value is stored in AX. No, that value is stored in BX by using move BX comma AX. Now again fourth, N4 is printed. What is N4? Subtraction of numbers. Subtraction of numbers means that message is printed on the screen. We used to print it on the screen. These three lines of code we need to use. So AH comma 2, which means printing of the subtracted value. AH comma 2 means higher order bit of subtraction value is going to print and BH value is stored in DL. And again AH comma 2 means the lower order bit of AL lower order bit of subtraction BL is stored in DL. Program is completed. We need to terminate the program by using this interrupt move AH comma 4CH into 21H. Now we use end to end the program. Now this is the program for addition and subtraction of two numbers dynamically. Now we save this program and we emulate this program using this run. We task enter first number. Now I give 6. So it is asking enter second number. So I given here 2. Now the output is see addition of two numbers 6 plus 2 is 8 and subtraction of two numbers 6 minus 2 is 4. Oh, that's it. So thank you. 8255 internal block diagram or 8255 architecture. We know that 8255 interface is between input-output devices and processor. So 8255 consists of 4 types of register, namely port A register, port B register, and port C register, and control register. These 4 registers are used to transfer data from input-output devices to processor or processor to input-output devices. Here, control registers are Group A control register and Group B control register. Either of these, any one of these control register is used. Both are same. So the data from the microprocessor 8086 microprocessor D0 to D7 is is stored in control register via 8-bit internal data bus. And port A is from PA0 to PA7 bits, and group B is from PB0 to PB7 bits, and group C. Group C is combination of port A and port C lower. Port A and port C lower bits PC0 to PC3 is named as group B, and port C upper and port B both are named as group A bits. These ports are used to transfer data from input-output devices to 8086 processor or 8086 processor to input-output devices, and this is a timer control unit. This unit consists of RD, which is a read signal, which is low, and you have to read data from input output devices to and processor or processor to input output devices, and write signal. This is also a signal used to write the information from 8086 processor to this input output ports or input output devices to 8086. So A0, A1 are two signals which represents which port is used to transfer data from input output devices to 8086 processor or 8086 processor to which ports it has to go. So if A0 and A1 values are 00, port A is used to transfer data from input output to 8086 or 8086 to input output devices. And if A0 and A1 is 01, port B is used to transfer data from input output devices to 8086 processor or 8086 processor to input output devices. If A0 and A1 are 10, then port C is used to transfer data from input output devices to microprocessor 8086 or 8086 to input output devices. And if A0 and A1 are 11, control register are used to transfer data from input output devices to 8086 processor or 8086 processor to input output devices. Here, reset pin is used to reset the interface 8255. If the processor sends data to the input-output devices, then the interface unit is reset for the new data, and the CS bar is low bit. Here, it requires 5 volts of 5 volts of power used to activate this 8255 processor, and which is linked with ground signal. Thank you so much.